Hello everyone, today I'm going to show you how to measure the area of a cell and the area of the nucleus. So we're going to start off by bringing in the picture and we're going to click on the Disable Global Calibration. We don't want that to be checked because I want this image to be calibrated. So Control-Shift-P, it should be 0.17 for a 20x image, global, that's perfect. So this image is calibrated. Now, the next thing we want to do is we want to measure the two channels separately, the red and the blue. The red is the cell shape. So we're going to go to Image, Stacks, Stacks to Images. So here we have blue and here we have red. So the first thing we're going to do is select a cell. So this cell right here corresponds to this nucleus. So we're going to go ahead and manually measure that. So what you do is, I have a pen, but you can use your mouse or your finger if you have a touch screen. We're going to select this little guy up there in the manual right there, that one. And we're going to go ahead and outline our cell. Okay, I made this full screen and now it's just easier to see where the outline is going to be. Okay, and then you press Control M. So that gave me my first measurement. So you can see here the name of your sample. The area is 46 microns squared. The perimeter is 261 microns. It also measures the circularity, which is 0.009. So not very circular. And then what else do we have here? Okay, I think that's all we care about. So now we press Control minus on the keyboard, and that will make your image smaller. So we can go ahead and move on to the blue channel right here. And this is the nucleus that we're focusing on. So again, we just like zoom in on it as much as we can. Okay, like right there we go. Okay, and then the same thing, we just shape the nucleus, Control M, and now we can go to our little table down here. There we go. So the area of the nucleus was about 10 microns squared, and the area of the cell was about 46 microns squared. So to get the nuclear area fraction, we just divide 10 by 46, but go ahead and include the decimal places. Okay, so my answer is 0.21. So that's about 21% nuclear area fraction. And yeah, that's it. Okay, so now we want to learn how to do things in an automated way. So the first thing we're going to do is reopen that image. And then we're going to go to image, type 8-bit. 16-bit is just too much. It makes everything require more computational power. So then we're going to go to analyze particles, or no. Where's the rest of my menu? Oh, it's not letting me. Hold on. Okay, now it's showing the arrow. So it just goes, you go down till you get to segmentation, and you want to go to trainable Weka segmentation. And then you want to, so we're going to create a classifier right now. So basically we're going to teach the software what we want. So basically right here, we're going to take this little peanut looking thing and we're going to start, I'm zooming into the center to show, not that one, we're going to take the circle. So we're going to go ahead and do that, and we're going to add that to background. And then I'm going to go to like all the corners and then just draw like a little circle right there, add that to background, and this to background, all the corners. Now the more area that you color in, the slower your computer will be, because it's just like a lot more memory that is required. Basically I have all the background, I think. So now I go into like wherever there's cells and I go in between the cells and then I just also do the same thing. Okay, then I want to grab this guy right here and I want to start tracing like one of the cells to show Weka, hey, look, this is what I want. This is like what is actually data. This is what I want you to select for me. So you're just basically teaching it what you want right now. And what this is called is creating a classifier. So you are creating a classifier so that Weka can use this classifier to actually segment the rest of your samples for you. So that was one of them, and I think that's enough. Let's go ahead and click Train Classifier, and this will take a little while. Okay, once the button's up here like this, then we're ready to go again. So it's done. You can click Toggle Overview, and then it'll show. But basically, this is what the software decided. Everything that you see green here, it was like, oh, that's green, but actually it looks like little red dots in between. So maybe we need to add some more green. Let's go ahead and do the circle. Let's show it that this is all background, so it should all be green, but it looks like it got the cells correctly. That looks yeah, that looks good. Okay, so we'll go ahead and teach it that this is all supposed to be background, and then you just train classifier again. Okay, it's done again, and so now what we're going to do is get probability, and this is going to see image will segment based on what you taught it. Okay, so this, if we were to save the classifier like this, then you can no longer modify it. Once you save it, that's how it's going to be. So here, these three cells were segmented really nicely, but this cell right here, if you notice, there's like a really bright section over here, but the rest of it isn't so bright. It's not so easy to tell, and you can see here in the nucleus, there's like little blotches, and so when it was segmented, you can see that there's like black in the middle. We don't really want that. We want it to like take the whole thing and make it white to count it as like the cell. So let's go ahead and reteach it. So I'm just going to go ahead and make that part bigger, and I'm going to go ahead and circle the whole thing and just be like, hey, this is supposed to be red. Add it to class 1, and then I'll train the classifier again. Okay, so now it's done. Let's go ahead and get the probability again. Okay, it's done now, and let's go ahead and compare these. So on the left, you can see the original image. Right here in the middle, we have the one where there was like a hole in the nucleus. And then right here on the right, you can see that the nucleus is pretty much covered. It did a good job, but there's background right here. Now this background is, I think it's fine because it's really small. So when we analyze the particles, it shouldn't show up at all. Like we can limit the size of the particles. Like we can say, oh, take anything that's 10 microns or larger. And if not, it'll just leave it behind and it won't quantify it. So it should be okay. So once we're happy with the classifier, actually, I'm going to go ahead and go in and teach it a little bit more, like right here in the center. I'll show it that that is actually background all right here, and I'll go ahead and train again. Okay, that took a really long time because the more you add, like I said, the longer it will take, but we're going to go ahead and get the probability again. Okay, this looks good to me. So we didn't get rid of all that stuff in the middle, but I think that's just because there are like fluorescent dots there. I don't know, but it's fine. We can go ahead and move forward. So all we're gonna do is save the classifier. And so I'm going to save it in this folder where it says classifiers, and I'm going to say 20x, 20x, and it's going to be raw merged images dot model, like whatever you label it, just put dot model. If you don't, it won't save the classifier. Okay, the classifier has been saved because we can now press all of these. So you can actually apply the classifier. So now you're going to look for where your pictures are that you want to use. I think we're here. Nope, I don't know what I accidentally pressed. Okay, so we can kind of start fresh. So what we're going to do is we're going to go ahead and grab one of these, any of them. We'll bring it in. Let's see, Control Shift P, make sure that the calibration is good, 0.17, that's great. Image type, 8-bit. Then we go to plugins. Then we go to segmentation, trainable Weka segmentation. Load a classifier. That's how you load the classifier that you want. I go by date, so this is the one we made today. Open, and that's going to take a little while. Okay, so we loaded the classifier, now we get probability. Okay, so then it's done, and let me turn off my AC. Okay, so it's done, and then this is what it gave me, and then our image is right here, I think. Nope, that's not the one. Our image is right here. Oh, I guess it was like that one. Okay, so then this is what it looks like. And as you can see, it's not like super accurate. Like this one looks good. Even though I wish it would have gotten the Philopodia, it didn't. Oh, it kind of did. Okay. But then it's not perfect because you can see right here, like this. Right here is the whole cell, and then right here we have a hole. So, but when we analyze our particles, when we use that function, it will be able to like fill in the holes, so we don't really have to worry about that too much. And then over here also, it didn't really capture the whole thing. So when we analyze particles, we have to take something into consideration. This right here is like 4 different cells, and it's all gonna be counted as one cell. And then when we click the fill holes function, it's going to fill this in, even though that's not actually a hole. So we're going to have to set size limits where we exclude certain sizes. So anything larger than whatever we decide won't be counted. But basically, and anything smaller won't be counted. I will basically want all the cells that are like this size to like this size or like this size. So you can get a nice range where you actually think they're individual cells. But yeah, basically this is your probability map, and we can analyze everything later, but basically this is like the inversion or inverted image, and then here we have our DAPI, and the same, the inverted image. So we will be able to classify like the red channel and then the blue channel separately. So then you just save this, you just save your image file, you save it as a TIFF, and then that's it for now. Okay, so whenever you have your classification result, you're left with this. Remember that there's like 2 things down here. But to move forward, we only want one. So the very first thing we're going to do is create a duplicate, Control Shift D. So you can select duplicate stack. We don't want that. We just want it to be unselected. So we only have one image right here. And then we can see that there's a lot of like stuff back here. So that's just noise. So we're going to go ahead and go to process, binary, make binary. And so now our image is like really nice and clean, and we can actually go forward with analysis. And remember that you always want to have your raw image here so you can actually see if something looks correct or if it doesn't, so that you know what you want to quantify. So like this cell right here, if you look at it, this is one cell right here and it has its nucleus, and then this red blob doesn't have any blue in there, so there's no nucleus. That's not a cell. That's like a cell fragment or just like dye, but most likely it's a cell fragment. But if you look at our classified segmented image, it's stuck together, so it'll be quantified as one cell. So we don't actually want that in our data. So something that we can do is we can go here, we select that square tool, and then we actually, because I want this cell right here, I like it, and I think we can quantify it. So we could just go like this. We don't even need that, actually, just like right there. Okay, and then you just press Control Shift D, and then you make, so basically that Control Shift D, because we chose that square selection, now we're only working with what we selected. The rest of it we can just like get rid of it. And now we'll just quantify this. And if we put Control Shift P, we can see that it's still correctly calibrated with a 0.17. So now I can show you how to get some quantifiable data out of here. So depending on what cell type you have, you're going to have to modify things a bit until you find what most accurately represents your images. So then we're going to go to Process, Binary, Watershed, and this function helps to divide wherever the software thinks that the cells are being divided. So we'll see how accurate this works or not. So we're just going to go to Analyze Particles. And I have from 30 microns to infinity. And then I put display results, summarize, add to manager, exclude on edges. So any cells that are like touching the edge are not going to be quantified. Include holes. You can do that if there's like holes within the cell, but these are different cells and there's a hole right here. So I don't want that hole to be filled up. So I didn't select that. Overlay, composite ROIs, and then what you want to show, outlines or bare outlines. I'll try bare, or do I want mask? Let's try masks. Okay. Oh wow, that looks really cool. That mask selection, but this is definitely not accurate. So that's what I mean. You have to play depending on your cell size. Like it's saying there's like 4 cells right here, when really it's just 1. Okay, so I went ahead and made another copy, and now we're just going to go to Analyze and Analyze Particles without that watershed function to see if this works better. So again, 30 to infinity, circularity, it could be any level of circularity. We want overlay masks. We want to try that again, and then we'll put OK. Oh, a threshold has not been set. We just had to make the image binary. So process, binary, and make binary. And now you can go ahead and use analyze particles. We'll keep all of that. And then this is so much more beautiful and more accurate here. So the software is still not able to determine that these are 4, 1, 2, 3, 4. These are actually 5 cells, 1, 2, 3, 4, 5 nuclei. So these are 5 cells, and it classifies them as 1 cell. So we don't really want that in our data. But this cell is beautiful. This one is beautiful. This one is beautiful. Actually, 6 doesn't even have a nucleus. So that's not something we want. 7 is beautiful. Yeah. So these are the types of measurements that you get. So we have the area for each of the cells that it labeled for you. We've got the perimeter. Remember, these are microns or microns squared. The level of circularity, the roundness, and then your summary table, how many cells did it find all together, and then like the same information, but as a summary. And then you have ROIs. So these are regions of interest, and it's like the same thing. It's like each of the cells, with all of its information. And then I think that's it. That's all the information that you get. So what I would do for this image is I would just copy and paste this results table, so you can just copy and pasted it to Excel. And then I would remove like number one on Excel. I would remove number one because if you remove it here, like you can delete it, but it'll just bump up the rest, but it won't relabel this for you. So it'll throw everything off. Definitely go to Excel, just copy and paste this, and then remove number one, number 6, the cells that we decided were not good, we just remove them. And then for the nuclei, it's actually a lot easier because they're so much easier to differentiate. So you just Control Shift D, you duplicate, and then you go ahead and make binary. So process, binary, make binary, and then process. Here we are going to use the watershed function. Okay, and I think it did a better job of dividing like this right here. Is 2 nuclei, and there's like a black line now where there wasn't before. Yeah, right there, dividing the 2 cells. It didn't do a good job of dividing this one because I'm pretty sure that's supposed to be 2, but then we go to analyze particles. So I think it's supposed to be different, not 30 to infinity. We can do like, for nuclei, it's probably like 15, and for cells, it's 30. Let's see. And then include holes. We don't need to. Okay. Let's see what this looks like. Oh, that's something else. Okay, so we're going to analyze particles, and we're just going to do 0 to infinity. Everything else will be the same. That's weird that it keeps bringing the cells along with the nuclei. Okay, so now from 15 to infinity, we're going to try 15 to 25. Okay. It says no particles were detected. Okay. Okay, I figured out a way to do the blue, and this is without Weka segmentation. It is a little bit faster, and I will record a macro for it so it can be automated. But I have to show you how to do it by hand first. So here you take your stack, which has your red and blue channels, your raw one. This is the one that we keep going back to. So then we go to images, stacks, stacks to images. Okay, we have our blue right here. We're going to make a couple of duplicates just in case we mess up with one, we can use the next. So the very first thing we should do actually is Control Shift P, make sure that we're scaled correctly so that our measurements are correct. Then we go to image type 8-bit. Okay, that's perfect. Then we go to, what did I do? Okay, so we want a threshold, Control Shift T. Control Shift T, let's see, Control Shift T, okay. So we thresholded, I like using Otsu, but you have a selection of different thresholdings available, and these are just segmentation algorithm type things. So we just want to select our nuclei, and because they're like nice and round and very bright, they're very easy to segment for the most part. Okay, so this looks good to me. I'm going to apply, and then I'm going to go to process, binary, make binary, and then process, binary, watershed, again to separate. And then we're going to go to analyze particles, and we're going to do overlay masks. That's good, from 15 to infinity. And then there we go. Boom. Look at how beautiful this is. And I'm going to make this large so you can see. It's gorgeous. Except right here, this is 2 nuclei and it counted it as 3. I think this is 1 and it counted it as 2. I think we'll do this without the watershed function, maybe. That might be better. Unless these big ones are actually, but then this one would have been counted as 2. Yeah. Let's do it without the watershed. So let's get rid of this. Don't save. We'll get rid of all of our numbers. Don't save. All of our Roys. Okay. Okay, so I redid it. Analyze particles. And this is without the watershed function. And it says we have 16. And so this is so much better. I wish it would have counted this as 2 nuclei, but it only counted it as, I mean, it's 1 dividing nuclei, so I don't know. But the rest of them look really good. They look accurate. The only thing is that this, like, number 1 looks really small. So I don't know if that's just like a tiny nuclei or if it's debris. Like all of these right here, they might be debris. We'll see. But we can always take care of that with our analysis. We'll just, with our analyzed particles, like instead of 15 microns, we could set it to like 20 or something. But we'll leave it for now. And then during class, I'll let you know if I want you to change it. But basically, these are our results. Again, we have our areas and we've got everything. Where is our, let's see. There we go. So here, that looks good. I like it. But let's try something else. Okay, so I did everything the same, but here, let's try, I'm going to leave it at 15. I'm going to take those little guys for now. We tried overlay masks a lot last time, and that was cool. Let's try outlines now. Let's see what it gives us. Ooh, this is cool. So these are the outlines. It actually, that's really cool that it gives you that, just in case we want to save it to submit it or put it in a PowerPoint, so that we know how like the software is actually quantifying the perimeter and area and everything. Okay, I like this one too though. But if you want to print it out, like print these guys out, then yeah, the other one is way better because this would just waste too much ink. Okay, so I did the same thing again, but now instead of outlines, we're gonna try bare outlines and see what that does. It looks the same to me. It looks the same as the other one. Let's look at it larger. Oh, it looks the same. I don't know. Okay, I did the same thing again, and now we're trying, I guess, count masks. I'll try that. That sounds cool. Ooh, so it just gives it to you like, but it said count masks, so I thought it was gonna be like numbered. Okay. Okay, so now instead of count masks, let's do normal masks. I don't think I've done that yet. Maybe. Okay, that's cool. I like that. I like this one. I wish it had the numbers on there, but that's fine. I mean, this one has a number, so I guess that's fine. Okay, and then I don't know if there's anything else that I want to try. Ellipses. What are those? Oh, no, that's not cool because it's just ellipses. It takes away the accuracy of whatever we had going on. So then I think that's all I wanted to try. Did we try outlines? Normally, I feel like we did. Oh, is that the one that has the numbers? No, it just has like a red dot in the middle for each one. Okay. Okay, so this is how we manually did everything. So in the next video, I'm going to teach you how to automate it.